It's 1:20 a.m. Robot's almost done. We got 34 hours left, and we've got a nearly finished robot. So let's see what we can do.
Have any outstanding items to add? Wire, cable manage.
We have the entire window motor and string.
3, 2, 1. Oh boy, oh boy.
That's a lot heavier than I thought it would be.
Fear me and my staff of window motors. This is to make the spool for the winch. The problem is that's like...
It's a lot of freedom for where it'll spool.
It's also... This is not strong. Right?
No, it's not.
Like, we have string and unlimited possibilities.
Adjust it up and down
on how we can put some sort of winch. It doesn't even have to be this tube. I was gonna 3D print an adapter for the window motor with some shape for it.
I mean, I think the tube is fine, Colin.
Yeah, I'm not saying. I just mean don't get caught on it.
Let's drive, and then we're gonna do a whole.
All right. We got it. Alright, that's gonna have. Okay, let's see. So that's.
We're gonna have to backdrive the motor a bit, probably.
2 inches. They don't specify. They really don't specify.
So you're probably gonna have to, like, you're pushing up against it pretty hard.
Yeah.
But
you also are not very square.
So what we just saw was that when we intook a ball, we had this shear off, and the ball ended up in the mechanism, but the chain was tangled up, and this is hanging off now. So we need to rethink this mechanism. It's kind of it seems like when the ball enters, kind of.
I mean, we can just replace them with bolts, right?
Okay, yeah.
We could just upgrade the rivets as well, right?
I think that's the quickest fix. I think that's a 10-minute fix, and if it works, it works. Yeah, let's just rivet this. Let's get the 3/16 fit, the rivet gun, and drill some holes.
Depends on how precise the arm controls are.
Oh!
Smack.
So those are backwards too.
Alright, put it down. Servo other direction. Good job, you broke the next thing.
I may have done because I hit down to go down, but down is up.
I mean, Colin did tell you to break everything, so.
The panel grabber mechanism is like an interesting design, but it might not be the best. And like what we've seen is that there's a couple of flaws in like it. You know, it does require a bit more torque than we were expecting to rotate that face panel.
Catch up
but
and
we've
down.
already got this.
But you could also
freedom.
tilt a catch up and down.
Yeah.
Instead of rotating it.
We have kind of low confidence in the servo.
Yes.
Great.
So we were trying to manipulate that. The pulley on the servo was like bending on the servo arm back and forth, and like that was where most of the motion was going into.
Is like this is causing us some issues.
Rotating.
We have over 24 hours left. We basically designed and built this entire robot in 24 hours. So I don't want to get in the mindset of like, oh, we built it, we have to use it. We could redesign this robot from scratch and potentially still finish on time.
If you increase the distance between the backstop and the little key, then the spacing between them, then you could just use that existing mechanism and just drive up to it, kind of half tilted down, pull it up, and then pull back.
I really like this mechanism, and it's very cool, and it has a lot of desirable features, but it might just be not achievable on our time scale or with our hardware.
This is a great thing that we can kind of show teams, like, here's a really cool mechanism that we might not be able to implement, but you may be.
Yeah.
Does anyone have any thoughts on that? Or is everyone just dead tired?
Yeah, we should.
Andrew's wide awake. He's not tired at all. He's having a good time.
You don't have a ton of Velcro here, so you might miss it. But it would be on the Velcro if all the Velcro was uncovered.
Why did you get all the Velcro?
To represent the brushes.
Oh, okay.
You just successfully deposited it without tension on the back panel, really.
Do we want to attempt actual lock-on, or do we want to just say, well, we're going to have a camera feed and we're going to have the driver do normal driver things?
The most flexible solution to this period by far is going to be a camera and a human keyboard.
Yeah.
Quick advice for some teams. If you can do it, bring extra USB cameras to competition and install them on your partner's robots. Like if they don't have it.
Yeah. How quickly can you drop in code to get that working on the dashboard?
I mean, it should be pretty quick,
In
right?
Q.
Like,
It's
3 lines of code.
It's 2 lines
Yeah.
for us in our code.
Okay.
Know for sure that the encoder was operating correctly before.
pretty sure it was.
It might be easier to see if I manually raise and lower it, so it's a little less jerky.
Mildly terrible.
It didn't change at all.
It's okay. It's okay, girl. You'll get there.
So right now we're trying to work on the PID controls for the arm so that we get kind of a smooth
I am really confused
movement.
because now this is built-in code or code from WPILib that is.
And now our build is failing.
There's no such file or directory.
So is the camera hold. Magic.
Walking through it one more time. We put the arm up, right, and then
Wheel engages.
wheel engages, which lifts the frame up to here or so.
Yes.
The rear wheels are still on, so we drive until that catches, and then as soon as that catches, we pull the wheel up. This is where we would do the arm. That's right. You do the arm and you lift the deck. That's right. And then you gain a little bit more. Now you use your 6-inch wheels. Yeah. So the idea is it's actually very simple. It's a stick with a wheel on it, not a driven wheel, just a free spinning wheel that you will articulate down in order to lift your front wheel up just to the point that it catches. And then from there, the wheel has done its job, it folds up, and the rest of the drivetrain takes over. And that gets you through the first half. We're able to use the arm on our robot for the second half, which is getting your second set of wheels up. And we were just messing with that, and we think it'll work out okay. Basically, the first problem is how do you get this wheel on, and then the next problem is how do you get this wheel on.
If we had a 6-inch wheel...
Yeah, that's what I'm saying. If we can get a 6-inch wheel by the time we get to competition.
Why are we running a 4-inch wheel?
Because we don't have 6-inch wheels. You want to know why our robot has 4 6-inch wheels and 2 4-inch wheels? Because I forgot to buy more 6-inch wheels.
We're trying to figure out a way to. What we want to do is we have a robot. What we want to do is we want to use this this gearbox to. So we're gonna stick a motor on this gearbox, and we'll get it up to speed so we can get a sufficient amount of torque to actually put an arm under our robot, so we can kind of lift ourselves onto like the 6-inch jump that we need to do to get to level 2 at the end of the game.
Still.
There we go.
We're not doing that. No one is doing that. We're not welding that.
Should I grease that?
Your
Sounds
box
like
must
beer.
be greased before use.
I mean, otherwise you just put it away and it's ready to use another day.
Go for it.
Yeet.
Stop saying that. Yeah.
I believe the phrase is, yeah boy.
What's your current opinion on the climbing mechanism?
I don't think it's going to work. Yeah. I mean, like, it might. I think it's worth a shot, and I think we'll learn a lot from doing it, and maybe that'll help us get to a solution, but I don't think this current configuration is going to work out.
I think the climbing mechanism definitely has a chance of working. I know that we can at least, I expect we'll get at least 1 to 2 inches off the ground. It's more dependent on the gearbox right now. We're running into some issues along that. But I honestly think this is a great idea. And I think based off of what kind of like mechanism we actually put on the ground, this could be really useful.
I do just want to point out that today we did learn something, which is that Colin is always right. So, take with that what you will. We're having 2 cameras recording each other. Camera fight! In this configuration, you can't see the little, you can't see where you're trying to place it.
Yeah.
I think making this out of a transparent material would really help.
Yeah, okay.
Do we have the Lexan for that? Because this would be the perfect view if it weren't half obscured.
Yeah. I want juice.
So I think if you have a good driver for this kind of robot, you can definitely score a lot of match points with this robot. Even if we can't get it to climb up the habitats, you can still get a ranking point from there if you have a robot on your alliance that can get up to be level 3, or 2 that can get to the level 2.
I don't know. I like the simplicity of the arm as a whole. It's something anybody could make, anybody could do successfully. It's definitely a solid framework, maybe for teams to base some of their own ideas off of if they're struggling to come up with a concept that's like reliable and robust. So
I honestly, I don't think Auton's dead, because I think there's so many ways that you could use like a little like 10-second like autonomous thing where you drive up and then you're like, okay, let me press this button to get it in line. But like programmers are still there. They have to program the robot in the first place. They can program all these routines instead of an Auton, which maybe is what they're going for. They want it less like fully autonomous. They want it more driving assistance sort of thing.
It's an interesting thought. They're trying to put more focus onto different aspects of it.
Yeah, which is interesting.
Have you implemented the limit switch yet?
Yeah. Pick it up.
We broke.
Oh, it just pulled out here.
So what are you gonna do? We're gonna crimp a ring terminal on. On the other end, we just crimped a connector on.
Okay, down a bit. Ah!
So if you do a slip knot, it can't come undone.
I don't know how to make a slip knot. Is this something where we want a washer?
I think so.
Yes.
I
mean, I can back drive it enough. Or no, I'm not back driving. I'm stretching. Oh.
Okay, so we need something with higher tensile strength.
Yeah.
We need steel cable.
Why didn't we get steel cable earlier?
I don't know. Just like, there you go, perfect.
Yeah.
Back up. There you go.
Hey.
That's it.
Right now.
It is 8:14 p.m. It feels like 8:14 a.m. But at least it's not 8:14 a.m. Or else we'd be 12 hours behind.
Is this a Colin bot status report that indicates that we're on time?
I think, well, it depends who's willing to stay until all night, you know? I mean, like, okay, so we're at the point where we've basically broken several of the parts, which is good. And, for example, the intake motor ripped off. The arm, we basically yanked the arm out of alignment and had to redo this sprocket there. Hatch panel grabber mechanism, we kind of were just tested it and it didn't work how we expected, and so we kind of just rethought many of the parts of the mechanism. And so that's good, because that means some of the things have failed, less things are going to fail now. Testing is a process of iteratively failing every part until there's no parts left to fail. And we're well on our way to do that. What do you want? A robot? You got yourself a robot. Place. Okay, drop it, back out, perfect. Hey. So that's pretty good, guys. What have we learned here? We've basically got this mechanism that seems to work on our rectangular game piece. It hasn't broken even when we smashed a wooden box, so turns out like string and wire aren't valid substitutes for like an 1/8 inch of steel. I mean, the stretch goal we set was climbing level 2, and so where's that at?
There's a lot of ideas that we've had. Most of them are infeasible because of time constraints and material constraints, which means money.
We just haven't had a solidified enough plan for anyone to take action on it, I think. Like, we've thrown out a lot of ideas and a lot of things that are like, yeah, that might work. Or, you know, like, that we could build that, but nothing where we've said, like, yes, this is the solution we're going to pursue. Okay, knowing what we know now about our robot, what are the odds we run out of things to do in the match?
I'm going to say not likely.
Who thinks that we can make a climber, like, if we had a couple more days, what's your confidence level of getting us to climb to level 2?
If we had more days, I would say, yeah,
I think we could. I don't personally have any significant ideas right now. But
Yeah.
in the frame of the competition.
And tell people that you're better off, like, building something simple and practicing than you are spending that practice time adding complexity.
Yeah,
like,
for sure.
yeah, so my opinion, and I think you probably know, is like I think that the climber is a cool idea, and I think it's possible like physically to do, but I think that we don't have the some of the resources we'd like, testing time or motivation to push that one through. So I think that we've like met all our goals in the sense that we've done them once, and it's just like practice and break things still and improve things if we see opportunities to do so. But like I'm really happy like we built our plan, I think.
Yeah.
You know, I mean, we were open to modifications along the way, and we built a thing that does what we said it would do.
I think I think it really, really helped that we took the time in the beginning to plan it very thoroughly.
Mm-hmm. Yeah, like, I think like looking back on it, we did take the right approach, and like, you could have said like, oh, you didn't have your CAD finished until whatever, you know, halfway through day 2, but we were done with the robot at the end of day 2, basically.
Yeah.
Like that's the kind of thing that if we hadn't done that CAD, or we hadn't taken that time to strategize it out, I think we would have been in a worse place end of day 2.
Oh. Drive a little faster than that. Yeah. Alright. Are you able to get off? Yes. Hey, you can do... But you're...
Oh! Wait, isn't that forward?
Yeah, that's forward.
Yeah. Yeah, it's flipped. I'll just do this. Ready, set, go.
Fantastic.
Oh yeah, that was fine.
This is really good. I really like the quick solution. The bolts are nice. Super simple. Height.
I brought your robot.
Okay, this is pretty tall, so let's do one thing.
We did a function check, and we're basically just finishing up the code.
Yeah, we're just about done here.
Yeah. Things are looking good.
Tear down that alliance wall.
There you go.
Move that This robot is the single greatest piece of engineering ever.
It's 3 days behind schedule.
This is like the pinnacle of human achievement. It is quite possibly perfection embodied in a robot.
You know,
Hey!
Let's turn the robot.
It did.
All right, new bolts time.
The bolts are sheared.
This is fine. No, this is not a hard fix. We're totally in the clear. It's just annoying.
Bolts which held the top of this gearbox on tore off, and they're now stuck in the holes of the top of the gearbox.
Yeah, okay, that's fun.
So it wasn't the
fun.
gearbox mounted to the frame. They're threaded holes in the top. So the way that the Versaplanetaries stack up is you have like an open slide on the different stacks and a closed side. If it's on the open side, then the bolt that's holding the gearbox together is experiencing a lot of shear force right here, which is not good for bolts, just from the twisting of the gearbox against the mechanism, because there's force going throughout all of these stages. So our fix for this is to make sure that the bolt is in this covered area as often as possible, and that the encoder, which has an open and a rounded slot, is the first thing in the stack, so that you aren't getting it up here at the end of the stack when it's gone through its, what, 100 to 1? Yeah. 100 to 1 reduction. So that's our fix. Hopefully these bolts hold.
This vastly exceeded my expectations. You've all done a very good job. We have a robot that was built on a very tight budget and a very tight time scale, and with no prior knowledge. And this is the first time we've ever done this, and I was kind of expecting to just like, you know, have a chassis and be like, all right, well, better luck next year. But this robot does things.
This is
pretty good.
This is going to be a pretty
If a rookie bot built this, that would be impressive.
And if not high-seated, this is definitely a robot someone might want to pay.
Yeah, and this is like, I think we can be proud of this robot. Like we didn't do bad.